So let's review a bit our mathematical properties of cross products. So this is just going to be a quick review of the cross product. This should be covered in Math 1920, but of course we understand that that might be getting a little rusty by now. So we'll do a little review on our cross product. So there are different ways of understanding the cross product. Basically, of course, as we've just said, you get a vector answer C when you do a vector A, and then you perform this cross product between the vector A and some second vector B. Now, there are a number of interpretations, of course, for the cross product. The most common way of interpreting it is the geometric interpretation, which is, of course, very useful. It's very intuitive. It's a good way to understand things. And when we think about geometric interpretations of vector operations, we want to understand, of course, our final answer, our vector C. Being a vector, C, of course, has a direction and a magnitude, so we need to specify both of those. The magnitude of C in the cross product is given by, it's kind of similar to the dot product. It's given by the product of the magnitude of A times the magnitude of the vector B. And like the dot product, it then also involves a trigonometric function, but it's the other trigonometric function. If this were a dot product, we'd of course use the cosine. In this case, it's the other product. The cross product actually involves the sine of the angle between the two vectors. So it's times sine of theta, where then theta is actually equal to the angle, right? That's a symbol I make for measuring the angle between the two vectors A and B. So that'd be the angle between vector A and vector B. So that's the magnitude. It, of course, has a direction. Now, the direction is given as follows. So the direction of C is specified as the fact that it has to be perpendicular to A, and it has to be perpendicular to B. Now, if you think about this, if I have any two directions in space, right? So here I'll give you, like, here's a direction A, right? Any two vectors. If I draw them, attached at their base, here's another one. Here I'll draw it kind of up like this, maybe. There's another vector B. These two vectors, of course, always span a plane. So there's some plane, I'm trying to sketch it for you here, that is spanned by A and B. So I kind of color that in. And then for a plane, of course, there is only one perpendicular direction to any plane. Well, actually, if you think about it, you have to be a little bit careful. There are two normal vectors to any given plane, right? You could either have sort of the upward one. I'm trying to draw this as though it were at an angle. So this would be one case, one direction that's perpendicular to that plane. And then there's the opposite one that would come out the other side, would also be perpendicular to it. So the direction is perpendicular to A and B. It's almost uniquely defined, but you have to decide whether it's the upward direction or the downward direction, because there are two perpendicular directions to any given plane. And the way that's determined is by the so-called right-hand rule. So it's perpendicular to both of those, but it also follows this right-hand rule. And that's something that takes a little bit of practice. So let's practice a little bit with our right-hand rule, and then we will move ahead to coming back to the physical kind of questions we hope to address with the cross product. So for practice, it helps to really be very familiar with how the right-hand rule actually operates with regard to our basic unit vectors. So let me draw a standard coordinate system for you here, right? So I would have I hat in the x direction, j hat in your standard y direction, and then here I'll have k hat coming out of the board here a little bit like so. And now the first one I might want to try to do here would be I hat cross j hat. Let's see what this combination gives us. Now, remember the logic. the direction of this thing, right, it's going to be given by the fact that the answer has to be perpendicular to both I and j. Now, I and j, of course, span the whole plane of the page here, okay? So there are really only two possible perpendicular directions that this answer could be pointing in. One perpendicular direction to my plane is k hat, and the other perpendicular direction is minus k hat. And the whole purpose of the right-hand rule really is just to help us to decide which of those two possibilities the final answer is. Right. So it's a little hard to try to draw this, but the basic application of the right-hand rule in this case is what you do is you take your hand, right, and you want to orient it so that your fingers are pointing along the same direction as the first vector, right? So here I might try to draw a sketch of a hand here. You'll forgive my sketching capabilities for hands aren't so great, but you know, we have 4 fingers, right? And then maybe we've got a thumb, and then there's maybe my hand. And the point here is that you start, when you implement the right-hand rule, you begin by having your fingers pointing here along the direction of the first vector. So you see the 4 fingers of my hand, not my thumb, but the 4 fingers are all clearly pointing here along the I hat direction. Now, the idea is you are supposed to, once you've got your fingers oriented that way, you want to rotate your wrist while you are keeping those 4 fingers pointing in the same direction. So you have to kind of, I'm trying to sketch this here, you know, you're trying to say here you want to try to rotate your wrist around. You have to decide which way you're going to rotate it. But you rotate your wrist around that axis until you reach a point where you can naturally curl your fingers toward the second vector, in this case, towards the j hat vector. So as I've drawn my hand here, of course, I can't really curl these fingers towards the j hat direction, right? That would be curling my fingers this way. I could try that, but very clearly if I did, I would probably snap my pinky, break my finger. That would be extremely painful. So that clearly is not the correct orientation for my hand in implementing this right-hand rule. So what you do then is you keep, you know, rotating that hand around until you find an angle for your wrist where you could curl your fingers towards the J direction. Now that's going to be a little harder for me to try to sketch again, but what will end up happening is you will end up with your palm pointing upwards. So see if I can try to sketch this here. So here's the bottom part of my hand. My thumb will be sticking out, right? Then I'm going to have my fingers lined up like so. Okay, I'm going to draw the other fingers, but I'm going to try to draw the other ones as they're curling upwards a little bit. 1, 2, 3. Oh, those are 4, right? They're not too bad, and there's a palm here. Again, I'm sorry, looks kind of like a monkey hand, but I think you kind of get the idea now that when my palm is face up, I can now curl these fingers towards the J hat direction. They are pointing in I hat, but by curling them upwards, I'm getting them to align more with the J hat direction. And I can do that, and that's fairly comfortable in that orientation. So I've now found the correct rotation for my wrist, and then the final end of the day is once you have that orientation, you look at the direction of your thumb, and your thumb then selects which side of the plane your normal vector should be in. And I have been careful here to draw a right hand. Be very careful when you do this, guys. The classic mistake, particularly for right-handed people, is because you tend to have your pencil in your right hand, you tend to start wanting to use your left hand, and you'll get the wrong answer. So you want to make sure to put your pencils down before you try to implement a right-hand rule. But with this hand in this orientation, you can see the thumb here is definitely wanting to point out of the page. So that selects my answer. It wasn't the K-hat direction. It must have been it wasn't the direction into the board. My thumb is selecting the direction out of the board. So it must have been the plus K-hat vector. Okay, so now here's an interesting fact about cross products. Let's see what happens if I try now J hat cross with I hat. What if I do that in the opposite direction? So in that case, as you can see, I'm going to begin with my hand pointing in my fingers pointing in the vertical direction. And then my job here, I guess I'll try to sketch this one too. So these two hands were trying to do I hat cross J hat. That's what I was doing here. Let's slide up a little bit. Let's try, see if I can do this again. If I draw my hand again, now my fingers have to point along J hat. So I'll draw my 4 fingers, 3, 4, right? Maybe I'll have my hand like this. So clearly my fingers are oriented in the correct direction along the J hat vector when I do it this way. And then my job is, again, I have to rotate my wrist around until I find a case where I can curl my fingers nicely towards the I hat direction. If I tried to curl my fingers now towards I hat, right, I would be snapping my forefinger to get that to point more along the I hat direction. That is clearly not a good orientation. So I would continue rotating my hand, and eventually I will end up with a case where my hand will look something like this. It's a little hard. I'm going to try to draw the back curved side of my hand here, and then I have some fingers. This is a very poor drawing, right? And then you can't really see the thumb very well, and my hand might look, here's the palm, something like this. I'm trying to show you here the fact that my thumb is pointing into the page, and now my fingers here, my palm, this is the palm. And now when you do this with your hand with the thumb pointing into the page, now finally the fingers can nicely curl in towards the I hat direction from their original orientation in the J hat direction. And when you do that, what you find is your thumb is pointing towards the inside of the page, which means then it's not the plus K hat, it must be the minus K hat direction. So that's an interesting mathematical fact, actually, about cross products. They don't commute. A times B is not B times A. These are what are called anti-commuting variables. They anti-commute. In particular, A cross B, as I said, is not equal to B cross A. It's minus B cross A. And I'll just label the fact here for my diagram, by the way, that I was trying to illustrate J hat cross I hat. Good. Now, you can continue down this list here. If we do I hat cross K hat, you can take your hands out. I'm not going to try to keep drawing these. Hopefully you're getting the idea of have practiced these before. The idea again is you put your fingers along I hat. You start rotating your wrist around, right, until you find an orientation where you can naturally curl your fingers towards the K hat direction. That's going to end up, if you're doing it yourself, you're going to find that your palm is going to be, you're going to really have to twist your hand around quite a bit, but your palm would be in the plane of the page so that you could curl towards K hat out of the page. Your thumb then, you'll notice, is pointing straight down, so that will come out to be minus J hat. And let's see, what else might we need? There's the J hat cross K hat. We haven't combined those two. And if you do J hat cross K hat, that one's a little easier. Fingers are vertical up, palm is towards you, fingers curl nicely towards K hat, and then your thumb will just pop out very nicely and give you the I hat direction. So I think you have a pretty good idea then of all the various combinations here that it could occur. Oh, I think there's one more we had better do, just to be very clear on these. So these are all of our nice coordinate directions. We've given you all the different types of combinations. It's nice that we know they anti-commute, so we can handle anything now. The one thing we haven't tried to do is, well, what happens if I take one of these and I cross it with itself? I hat cross I hat. Well, If we think about the magnitude of this, we'll find the following. If I want to calculate that, the magnitude of I hat cross I hat is going to equal, according to our formula, the magnitude of I hat times the magnitude of I hat times the sine of the angle between them. But remember, the way we measure angles between vectors is we draw both vectors, so these will be I hat, with their bases together, and you measure the angle between them. Well, now I have two identical vectors. I won't draw them quite as identical, just so you can see what's happening, but they're almost identical vectors, right? Two I hats, and then theta would be that angle between them. In this case, theta would be 0, and the nice thing is that the sine of 0 actually equals 0. So we get 1 is the magnitude of I hat, right, times 1 is the magnitude of the other I hat, times 0, we just get 0. So another handy fact, aside from this anti-commutation relationship and these answers we have for all of our unit vectors, the other handy mathematical fact is that any vector cross product with itself will actually, of course, give me a 0 angle, and then that also tells me that the cross product between them is going to give me 0 as the magnitude, and the only vector with 0 magnitude, of course, is the 0 vector, and we just get 0.